Bismillahirrahmanirrahim. Our next topic name is matrix inversion method, and it is the continuation of the previous topic in which we solve the question by using Cramer's method. So I take the same question so that you can see how two methods give the same answer. One thing you must keep in your mind, there are different methods, but their answer is unique. So we find the solution by using now matrix inversion method. I take the same question number 1. It is 3x minus 2y is equal to 7. 2x plus 4y is equal to 10. In the same way, we have to convert this system of equation in matrix form. First of all, the first matrix that contain the coefficient of the coefficients of this equation, so it is equal to 3 minus 2, 2, 4, and then the second matrix contain the variable of the equations that are x and y, and the last matrix contain the solution of the equation, that is 7 and 10. Last time we name it, this is called the coefficient matrix, this is called the matrix of unknown, and the last one is called the solution matrix. In this method, first of all, we find the inverse as we done in the previous lecture. First of all, we find either this matrix is singular or non-singular. If non-singular, then we find its solution, otherwise we stop here. Let we name it, let this is matrix A, this is X, and this is B. In this way we get a system AX is equal to B. Now we take A is equal to 3 minus 2, 2, 4. We find its determinant. A determinant is equal to mod of 3 minus 2, 2, 4. Now what we do, how we can calculate this determinant? By multiplying the main diagonal elements. As I was telling you in the previous lecture, these elements are called the elements of main diagonal, and the other two are called the elements of the secondary diagonal. So first we multiply the main diagonal elements, that is 3 and 4, then operation sign negative, then 2 and minus 2. On simplification we get 12 plus 4, this is equal to 16, and it is not equal to 0. It is a non-singular singular matrix, so its solution is possible. This method is a little bit different from the previous one, in which we have to find the inverse. We have to find the inverse, and its formula is A inverse is equal to adjoint of the matrix A divided by A determinant. And how we can find the adjoint? What is adjoint of A? Adjoint of A means we have to interchange change the places of the elements of the main diagonal, change the place of elements in the main diagonal. So in this way I write 4 3 and change the signs of the secondary diagonal elements. Change the sign of the secondary diagonal elements. So it becomes -2 and +2. In this way you get the adjoint. This method is only for the 2 by 2 system, not for 3 and other. It has some other changing methods. So you can adopt this method only for 2 by 2 system. So adjoint of A is equal to 4. You have to change the place of the main diagonal elements and change the sign of the secondary diagonal elements. In this way you get the adjoint of A. Now we find A inverse. This is equal to adjoint of A divided by A determinant. I write here what is the value of determinant, that is equal to 16, and further I write the value of the adjoint, that is 4, 2, -2 and 3. The system that I write in this form, I name it equation number 1. Now by 1 I write AX is equal to B. Now I am doing, I want to cancel this A, or I say I try to take this A towards this. So how it is possible? So pre-multiply both sides by A inverse. So you get A inverse AX is equal to A inverse into B. Here this A is cancelled with this A inverse. You get only X is equal to A inverse B. Now you substitute here the values. We have the value of X is, as you see, X is equal to XY. So I write here at the place of X, X, Y, and A inverse, you see here A inverse is equal to 1 by 16 into 4 minus 2, 2, 3. And then the value of B, that is equal to 7, 10. 7, 10. Now how we can multiply these two matrices? You have to multiply these matrices in this form. You multiply the elements of row with column. First you multiply the first element of row. First you multiply the element of first row with the first element of column, and the second element of row with the second element of column, and add them. In the same way, the second time you multiply, the same work is performed with the second row. You first multiply the first element of row, second row with first element of column, and second element of row with second element of the column. So you see here 1 over 16. I multiply 4 with 7. 4 multiplied by 7, and then put up a positive and plus sign. Then you multiply the second element with the second element of column. It is 2 multiplied by 10. In the same way, now you move towards the second row. You multiply the first element of second row with first element of the column. This is equal to 2 multiplied by 7 plus, and second element of row with second element of column, 3 multiplied by 10. Now I try to simplify this. This is equal to xy is equal to 1 by 16, and after simplification 8 fours are 32 plus 2 tens are 20 minus 14 plus 30. Now 1 over 16, this is equal to 32 plus 20, this is equal to 52. Now sorry, one thing I during multiplication I do one thing wrong, that is 7. That is 7. So it is equal to 28. So in this way you get 48, and 30 minus 14, this is equal to 16. And you get, when you divide both the elements with 16, you get 48 divided by 16, 16 divided by 16, and your answer is 16 threes are 48, 16 ones are 16. So in this way you get x is equal to 3 and y is equal to 1. So our solution set is 3, 1. And you can see from the previous, you can see here, and the same value we find it in the previous lecture through Cramer's rule. So methods are different, but answers are unique. It is our continuation towards, we have I am teaching you these methods, that's why, because we are further moved towards the advanced techniques of finding the solutions, in which you see in exercise number 3.2, solve the equations by using Gauss elimination method and Gauss-Jordan method. These two methods, first the Cramer's rule and the second is the matrix inversion method, these are the continuation of Gauss elimination methods. Now, how you can perform these questions, first you must have knowledge, of these methods. So that's why I am solving these questions by using these two techniques. Then in the next lectures we will inshallah ta'ala see how we can use the Gauss elimination method and the Gauss-Jordan method. In these methods we use the row operations. How you can use the row operations method, inshallah ta'ala I will tell you in the further lectures. So you can able to solve questions of exercise 3.2 with Cramer's method and matrix inversion method. Okay, take care. Allah Hafiz.